Hi, everybody. So it's 2 p.m. It's now time for our Atlassian and Docker webinar. So we're going to go ahead and get started. My name is Brendan Kaplan. I'm the Senior Marketing Specialist here at AdTech. AdTech is an Atlassian enterprise expert serving an international market. We're also the largest Atlassian expert in our metro region, which is New York City. And we focus primarily on software configuration management, build and release management, and automation. In addition to our Atlassian offerings, AdTech stays ahead of the trend in continuous integration for database deployment, non-Atlassian DevOps tools, and other innovations. As you probably know, Docker is used to provide dev teams with everything that they need in order to easily provision containers. Users can put anything they want into containers. And today, we're going to be putting Atlassian's tool Jira in, but you can create any environment you want. And in future webinars, we're going to be focusing on Bamboo as well as other Atlassian tools. So I'm Brendan Kaplan. As I've said a few times, I'm the Senior Marketing Specialist here at AdTech, and I'll be providing my contact information immediately after this webinar. And our technical presenter today is Himanshu Chetri. He's our Senior DevOps Engineer, and he's a really wonderful source of information. So we'll be providing his contact information at the end of this webinar as well. So let's dive in. So what we're going to be covering in today's webinar is first an introduction to Docker. Now we're going to show you a quick little hello world example, which uses Nginx to demonstrate the Docker registry, images and containers. After that, we're going to show you how to instantly provision an instance of Jira. And then we're going to talk about using Docker as a way to test the success of your Jira upgrades. We're going to do a Q&A afterwards. So if you want, feel free to submit your questions throughout the webinar. And as I mentioned, copies of presentations will be distributed to attendees upon conclusion.
Thanks for the intro, Brendan. So like Brendan mentioned, today's topic is a basic intro to Docker, and then we will also be exploring the use case of basically provisioning a test instance of Jira, as well as performing a test upgrade by utilizing the different functionalities offered by Docker. But before we go into the use case that we have for the end, at the end of the webinar, let's first dive into some basic concepts behind what is Docker and what are some of the major use cases and why it's creating a whole lot of buzz right now in the DevOps space. Now, if you approach anyone who has dived into Docker or has utilized Docker in some form or the other, and if you ask them what is Docker, you'll probably hear a wide range of answers, ranging from it's helped simplify the way they deliver software all the way through it's made the life easy both for developers as well as operations. And the best definition I came across for what is Docker, it's on the official Docker website where they call it an open platform for developers and sysadmins to build, ship, and run applications. That's because Docker is not only a tool chain, but it's also an entire platform, and is also a workflow for the way you build, deliver, and deploy your applications. But why Docker? That's a question we need to address. So the major purpose behind Docker is to improve the way software is delivered, both in terms of speed, efficiency, as well as the entire model of making it more simple, both for developers and operations. Currently, many organizations are struggling with the way software is delivered. That's because developers deal with the intricacies of the applications. They deliver the source code, but then when operation needs to deploy this to different environments, they still need to deal with the intricacies of the application. They cannot completely detach themselves. The reason being, anytime developers are working on developing their applications, there are some specifics and details about the environment itself that you cannot easily propagate when you deploy your application to different environments. And that's where Docker comes in and it eases and simplifies this whole process, where developers are not only delivering source code for the application, but they are also delivering the entire environment required for running the application. So it easily allows them to decompose the application into different services and then define different Linux containers that represent these services, and these can be delivered and consistently deployed across multiple environments. The second advantage of using Docker is the ease of deploying it to multiple platforms. So for instance, as a developer, you can define your application's environment in your own workstation, and you can then take your application from the developer's workstation and deploy it to a physical server, or you can deploy it to even a cloud server. So there's no limitation almost in terms of where and how you can deploy your Docker containers, as long as they're running a fairly recent version of Linux that Docker supports. And the other advantage is it also is lightweight. Now, if we talk about the overall advantage of how it provides an isolated environment, it may sound a bit like virtual machines, but in the case of Docker, it leverages Linux containers, which are a lot more lightweight. And what this enables is very quick provisioning times, where most of the time when you're provisioning a Linux container using Docker, it's less than a second to provision it. And you can start to think how this would also play an important role in scaling out your application. So when you are on the cloud, or you're trying to implement a cloud-based model where you want to elastically scale your application as your need grows, you need to be able to rapidly provision new environments. And the other aspect of it is, if you are using containers to also extensively test your applications, you need the ability to both provision as well as tear down your test environments. And compared to use alternatives like VMs, Docker is a lot more efficient, it's a lot quicker and faster, and thus it contributes towards the overall speed up of your software development lifecycle. And all of these also overlap with some of the best practices of continuous integration and continuous delivery. In continuous integration and delivery, you have different patterns like immutable environments, blue-green deployments. All of these common patterns can easily be incorporated with the Docker workflow. And best of all, Docker is not only a tool chain, like I mentioned earlier, but it's an entire ecosystem. Docker itself has tools ranging from tools that let you manage and create Linux containers all the way through running your Linux containers in a clustered environment, as well as also providing a platform for you to be able to easily distribute your Linux containers. And we'll be diving into details of these. And apart from Docker Inc., which is the company behind Docker, there is a wide range of supporters in this space creating tools and services around Docker. In fact, the support for Docker has even extended in the Microsoft ecosystem, where recently they've announced that they will also be adding increasingly more support to provision Windows environments with Docker. And when you initially describe Docker to someone who's new to it, they usually ask, what is the difference between Docker and VMs? And this diagram is a simple representation of the architecture of a VM, or a virtual machine, where you have your server and you have the host operating system. And then in the case of VMs, you also need a hypervisor on top of the host operating system. And the hypervisor itself is fairly lightweight and does not add a whole lot of cost in terms of resources. However, the major cost in this scenario is the cost of the guest operating systems. So when you are deploying your applications inside of virtual machines, you not only need the VM, but you also need a guest operating system running inside of the VM. So what this limits you is it adds the cost required for running the guest operating system. It contributes to a slower provisioning time, where instead of being able to provision in less than a second, it might take you several seconds to provision the guest operating system for the VM. On top of that, there's also the resources in terms of memory and CPU that the guest system requires. And what this does is it also reduces your overall capacity of the server, where you are limited to a certain number of virtual machines that you can run on top of it. Now, if we move on to the Docker model, again, at the base level, we have the physical server and the host operating system. But instead of the hypervisor, we have a very lightweight layer, which is the Docker engine. And you'll notice that what the Docker engine enables you to do is similar to VMs. You can create encapsulations. You can encapsulate your applications in isolated environments, but without the overhead of the guest operating system. So at a very high level, the way you can understand this is basically it gives you almost the same benefits as virtualization, but without almost any of the overhead. And basically, by removing that extra overhead of requiring the guest operating system, you are able to rapidly provision containers using Docker. Now, in terms of the architecture, Docker is based on a server-client model. So you have the Docker client, which usually is in the form of the Docker command line. So you use the Docker command along with a subcommand like Docker pull or Docker run. And the Docker client then connects to the host. So the host basically will run the Docker daemon, which can create, manage, and provision containers out of different images. And the way Docker client communicates with the host is either over sockets, or it can also communicate using the REST API. So that's the best thing about Docker is the host exposes a REST API, and that's one of the other reasons why you see a wide array of tools built around Docker, which is possible because of this API. And then the Docker client may or may not be on the same host as the Docker daemon. So you can also use the Docker client to connect to remote hosts. And the Docker host in turn connects to a Docker index. And this is also another really powerful feature of Docker. So for instance, anytime you're trying to provision a container using an image, what the Docker daemon will do is it will initially look for a copy of that image locally. And if it cannot find that, then it can connect to the Docker hub. So the Docker hub is a public registry with a lot of open source images for different Docker-based applications. And it can automatically download a Docker image if it doesn't find a local copy. And that is the same sort of workflow we'll be utilizing for some of the examples we'll be showcasing today. But basically, it's a fairly straightforward architecture in terms of how it's a client-server-based model. And then the server, in turn, is also linked to the Docker hub, which is a public registry. Also, another thing to note is if you are planning to use Docker to do your enterprise scale deployments of your applications, then you can also link Docker to your own private registry. So you're not limited to only connecting to the public Docker hub, but also you can link it with your own private registry. And that also serves as a powerful way of distributing your applications and services as containers. And there are two other terms we need to familiarize ourselves with, which is the Docker image and the Docker container. And if we break down the architecture, we can think of image as a read-only template for creating containers. So basically, you are able to write to the container, but you basically instantiate containers out of read-only images. The images themselves at the file system level are composed of a combination of different file system layers, and these layers are combined into an image by utilizing the functionalities offered by the union file system. And the Docker daemon is responsible for creating a container out of this image. And anytime you provision or create a new Docker container, it has its own set of unique properties. So it has unique properties ranging from a unique ID. So it assigns a random unique ID to a Docker container, which is a SHA checksum. And then each Docker container has its own network and network settings. And you can basically specify the different sort of network settings, like the ports you want to expose and so on. And then optionally, you can also set resource limits when you are creating these containers. So the best way to see this in action and get a practical understanding is to create a very simple container. In my case, I'm going to run this command, and then I'll get back to explaining what this is and what it will do. So I'm going to go to the terminal, and I'm going to run this Docker command. And you will see that when I use a Docker run command, it gives me this SHA checksum, which indicates that it was successfully created. Now, if we go back to this command, we can see that we ran the docker run command, and we specified a couple of different parameters. So we are running docker run along with passing the parameter that we would like to create a container out of the Nginx image. So Nginx is a very popular free and open source web server. And in this case, Nginx also runs on port 80 by default. But since it's exposing port 80 inside of the containers network space, we want to, however, be able to access port 80 from the host. And in this case, we are mapping port 80 to port 7001. And the way we do that is by passing the -p flag, which lets us specify the port number and how it's mapped to the host. And we also pass a parameter called -d, which basically runs the container in detached mode. So by default, it invokes the containers in the foreground, but in this case, we'd like to run it in the background, and we pass the -d flag to detach it. So if this was successful, then we should be able to access the default page for Nginx by accessing it using the port 7001 for the host system. So we can go to this address. This is the IP address of the host system, and then we access port 7001. And what we get is a basic welcome to Nginx page, which is the default page that you get when you install Nginx. Now, to demonstrate how powerful this simple example is, I can repeat the command from earlier, and this time I will create a second container. However, since port 7001 is already occupied, this time around I will expose the second instance in port 7002 by simply modifying the port mapping. And if I go back to my browser, I can now access 7002, and it gives me the same default welcome page for Nginx. Now, the question at the end of this example might be that how exactly do we track containers? How do we look at the details about the containers that we just created? The answer to that is to run the docker ps command. So if we go back to our terminal, and if we run docker ps, so we get this output, and then there are basically two rows of output along with different columns. So we can see that the first column is the container ID, which is a short form for the Docker SHA checksum. Next, we have a name for the container. So anytime you are using commands, next is the image, and that is the source image for the container. In this case, it is the Nginx image. And then we can also see internally what is the command being used, and we can also see when it was created, as well as how long it's been up. And we can also see the port mapping, being what are the different ports being exposed inside of the container. So in this case, it's internally exposing port 443 and 80. However, we've only defined mapping for port 80. So in the first container, it's being exposed on port 7001, and in the second one, it's being exposed on port 7002. There is also the last column, which is a name for the container. And we have the option to specify a name for the container, and in our case, we did not explicitly specify one. So what Docker does is it randomly creates a more human-friendly name for the container. So in this case, one of the containers, it came up with the name Morris Shockley. But optionally, you can also define your own names for easily being able to track what each of these containers do. So by running the docker ps command, you're able to list your containers and the details regarding them. So the next example will dive into something more significant. And I'll get back to explaining what this example does. But since this example takes a couple of minutes to run fully, I'm going to run the command and then get back to the slides to explain what it does. So the next example will deal with provisioning an instance of Jira. And we use the docker run command similar to the last example, but there are a couple of extra flags that we've used in this example. And before we understand and dive into these flags, I guess it's important to note the Docker image that we're using. So in this case, we are utilizing a Docker image from the Docker Hub. So in terms of the official support from Atlassian, Atlassian has not released official image for Docker for any of their tools, apart from Stash. So they have released a official image for Stash, but however, there isn't one available for Jira yet. But a developer advocate from Atlassian by the name Nicola, he's created a really nice image for Docker and a couple of other Atlassian tools on the Docker Hub. And in this case, we forked the example from Nicola, and we made some very simple modifications to it, to the fork. And if we dive into the entire command and the different parameters we're passing, so we are using the docker run command, and then the last parameter we're passing is the name of the Docker image. So in this case, we are using attic/Jira, which is the namespace defined for the Jira image under the attic account on the public Docker Hub. And then you'll also notice something different compared to the last example, which is we are providing so in this case, we are providing Jira :6.2.5. So Docker has this feature where when you're creating a container, you can also utilize any of the tags that might exist for that particular image. So in our case, when we forked the Jira image, we also created two different tags. One for basically pointing to version 6.2.5 of Jira, and then we have a different version of Jira, which we'll be using to test the upgrade scenario. And the other major difference is this time along, we are also using the -v flag. Now, if you want to persist data in your Linux containers, then it's ideal to utilize Docker volumes. And in this case, we are also mapping our Docker volume with a directory on the host operating system. So we are utilizing a directory called Jira Home, and we are mapping it to the Jira Home directory. Now, to understand what the Jira Home directory is, we can basically decompose the architecture of Jira into three major components. One is the Jira installation directory, which is based on the specific version of Jira. Second is the Jira Home directory, which typically would store the attachments and some configurations. And then we have the database. But in the case of our example, for the simplicity of the demo, we are not using a dedicated database. So instead of using a dedicated database, we will be using an embedded database, which again is not meant for production scenarios, but it suffices for creating a test instance of Jira. So what we need to keep in mind is we are definitely not advocating using Docker to deploy Jira in a production setting. The reason being, one of the main reason being is that there is no official support from Atlassian yet, which might change in the future. But until then, what we recommend and what I think even Atlassian recommends is using Docker as your test environment and not using it in a production capacity at this time. And if we go back to the terminal where we invoke the command, so I'll scroll up a bit. So you'll see at the top, we invoke that command, and then we see a lot of logs which are associated with the Jira startup. And we are exposing Jira on port 8080 on the host system, and internally as well, it runs on port 8080. And if that worked, we should be able to go to port 8080 on the host interface. And momentarily, that should bring up the Jira setup page. And there we go. And on the Jira setup page, we are given a choice for the database connection. And again, in this case, we will be using the built-in embedded database. But if you do have a dedicated database, then you are able to point to that as well in this step. So we will have to complete a few other steps to complete the Jira setup. Should only take us a couple of minutes. And you'll notice that we are able to see all of the logs associated with the Jira setup and the Jira startup because this time, unlike the Nginx example, we did not use the -d flag, which detaches this and sends this output to the background. And we need to use the docker log command if we are running the container in detached mode. So by using the docker log command, we are still able to access the logs. And we can see that we get a message that Jira probably has finished that last step. Now, next, we need to provide a title for our Jira instance. I'm going to call it Demo Jira. And we are going to quickly generate an evaluation license for our Jira instance. So you would require an account on my.atlassian.com for being able to generate the license. And we should probably have one more step remaining, and we should be all set after that. And we should be able to log in and access our Jira instance if that was successful. Okay, so we have a couple of steps. We need to provide the admin username and password for our Jira instance. And that should be the last step. After this, we should be able to log into Jira. And while this loads up, if we talk about Jira, Jira is probably one of the most popular issue tracking tools and issue tracking and project management tool out there, which is not only used by software development teams, but also by a wide range of teams that want to track their issues in Jira. And there are also several add-ons that really make Jira a powerful platform for getting things done in an agile manner. So now that we finished setting up Jira, we are logged into the default Jira dashboard. And if you're new to Jira, Jira basically stores issues under projects. But in our case, since we just set up a new instance, we don't have any projects. And until we have a project, we cannot create issues. So we are limited to that. So let's create a test project. So when we go to the option to create a new project, there is an option to create a demo project. We'll choose this option. The nice thing about this demo project is it also comes with a couple of issues that contain some data. So now it created the demo project with 6 issues, demo 1 through demo 6. I'll also create an additional issue because we'll be using that as a very simple test to validate that the upgrade will be successful in the next step. So I'm going to create a new Jira issue. And I'm going to choose the issue type task. I'll call the summary demo Docker with Jira. I'll assign it to myself. I'll also provide a short description. And then, like I mentioned earlier, all of this data for our test instance of Jira is being persisted in the Docker volume, which is mapped to the Jira home directory. And that's also responsible for persisting any attachments associated with our Jira instance. So in this case, I'm going to attach the Docker logo to our Jira issue. I'll click on Create. And now when I view the issue, I can see that this is demo 7th, which is the 7th issue that was created on the demo project. And just to recap, the version of Jira that we have on our instance is version 6.2.5. Let me highlight that. So we can see that this is version, the version of Jira in this case is Jira 6.2.5. So this way you can see that we provision Jira fairly quickly by utilizing Docker. And in fact, we can proceed to creating multiple instances of Jira. All we would need to do is we would need to specify a different port mapping on the host networking interface. And we are only limited by the physical resources of the server. And we can theoretically create as many Jira instances as we'd like, only limited by the underlying resources of the server itself. And the next step is we'd like to test upgrades. So being Atlassian partners, we work with a wide range of clients, and they require the ability to be able to instantly provision Jira test environments in order to test different things, ranging from major configuration changes to trying out new experimental modifications and upgrades. And upgrades are a major use case where sometimes you want to be able to provision a quick test environment where you can try out a new version of Jira and then basically determine whether you are ready to do that upgrade on production or not. So for the next step, I'm going to run 2 commands in Docker, and then I'll get back to explaining what those commands will do. So I already have these commands ready in my terminal. So we will start the upgrade by simply invoking 2 Docker commands. The first Docker command is going to stop our current Jira container. We gave the name demo Jira 6.2.5 to our current instance of Jira, which is Jira version 6.2.5. And then we are going to create a new Jira container, and this time we are going to give it a name, demo Jira 6.4.1, indicating that we want to this time utilize Jira version 6.4.5, 4.1, which is the most recent version of Jira. Similar to the last example, we will map port 8080 to the same port inside of the Docker container. And this would error out unless we stop the previous instance. That's because the previous container was already mapped to port 8080 on the host system. So unless we stop it, we cannot have 2 containers mapped to the same port on the same network interface of the host. But when we stop it, that frees it up, and this enables us to utilize the same port number for our new container. And the main subtle change and difference between the last command is this time when we specify the name of our image, we specify @Jira, and we provide the tag for the Jira image, which is linked to 6.4.1. So the fork of the Jira image under the attic account has 2 tags, like I mentioned earlier. One is for version 6.2.5, and the other one is for version 6.4.1. And if I go back to my terminal, the command has started running. It's in progress. It might take a couple of minutes for it to complete because it's going to basically start the upgrade process. And at this point, one of the questions that might come up is, should you use this in production? And like I mentioned earlier, this is definitely a better fit for testing upgrades, and we definitely don't we don't recommend using this in a production scenario. But you can see that as the support from Atlassian grows around Docker and the Docker ecosystem, this could someday become a very powerful mechanism for delivering different Atlassian tools, as well as being able to rapidly provision any version of the Atlassian tools, as well as testing upgrades. And the other question might be, how exactly is this new container linked to the previous instance of Jira? So if we go back one slide, and we talked about how this version of Jira, which is Jira 6.2.5, was linked to a directory, which is the Jira home directory. And this is a directory that exists on the host file system. And this is mapped to the Docker volume for opt Atlassian home. In the case of the Jira image that we are utilizing, the Jira home directory is stored under opt Atlassian home inside of the Docker container. And then because we specified a Docker volume, all of that data will persist on the Jira home directory of the host system. And in this case, when we are attempting to use Jira 6.4.1, the common factor is we are utilizing the same Docker volume. So you'll notice that the Docker volume is consistent with the last example, where even in this case, we are linking it to Jira home directory, which maps to the opt Atlassian home volume inside of Docker. Now, in a more realistic scenario, when you are testing upgrades, something you may want to do is also back up this directory, which serves as a Docker volume. This way, when you back up your Jira home directory on the host operating system, you also have a copy of the home directory linked to the previous version of Jira. And if you want to go back and forth, you have the ability to do so by running the older container linked to the previous version of Jira and pointing it to a previous copy of the home directory. If we momentarily switch to the terminal and refresh this page, might still take another minute or two to complete. And looks like it's completed because it's loading up the login page. If we go back to the terminal and if we scroll up, we should see some indication that a Jira upgrade was performed. So there are some logs which indicate that it is running Jira version 6.4.1. And if we scroll further up, we also see some logs commonly associated with upgrade, because we can see some indication that it has upgraded the database schema according to the new version of Jira. If we go back to the browser, we can log into our new instance. And we are able to access the same issue that we created earlier, which was the Jira issue with the Jira issue ID demo 7 with the summary demo Docker with Jira. And then we are also able to access the attachment linked to that particular issue. Now, we also want to be sure that we are running Jira 6.4.1 and not version 6.2.5 prior to the upgrade. And we can zoom in to the bottom of the page, where we can see that we are currently using version 6.4.1. And we can also check the other issues in our demo project. And if you remember, we had 7 issues after we created our test issue. You'll also notice some changes in the Jira user interface associated with the most recent version. And if we list issues in our demo project, we're able to access all of the test issues from earlier. And this is how we can conclude that the Jira upgrade was successful. And you can see that this was a very simple yet powerful way of both provisioning Jira as well as testing the upgrade scenario, along with the flexibility of being able to roll back to earlier version if required. That's it in terms of the demo portion of our webinar. Like Brendan mentioned, we will be posting all of the materials as well as the webinar recordings. Next, we'll open up the floor for Q&A. And if you have any questions, feel free to please post them on the question section. So we'll leave the floor open for a couple of minutes for questions, and we'll wait until then. So we have a question from Andrew, and he has a really good question. His question is, what would you do about configurations such as server.xml? So if you're not familiar with the Jira architecture, then Jira has a key configuration file called server.xml, which is associated with the underlying Tomcat instance that Jira deploys to. And if you're using Jira in a production environment, then you would most probably end up modifying some configuration or the other in server.xml. And Andrew's question is, how would you persist this when you are doing your upgrades? So now the best answer I can think of is you can complement Jira with a configuration management tool which automates applying any sort of configuration, including server.xml. So for instance, what we advocate is you can use a tool like Puppet, Chef, or Ansible, which should contain all of your modifications to the Jira configuration. That way, you can consistently apply your configuration regardless of whether you are provisioning your Atlassian tools or Jira instances inside or outside of a Linux container, and you can keep it consistent. So it is a fairly common pattern that when you use Docker and Linux containers, you can also continue to utilize your current set of configuration management tools to consistently apply your configuration changes. And also, Docker has the mechanism for building Docker images using the Docker file. So when you look out for examples, sometimes you might see someone attempting to use some shell script or some other mechanism to do that within the Docker file. But again, in a production scenario, you might be probably best off using a proper configuration management tool. Okay, and let's move on to the second question. Okay, so the second question is from Adam, and he's asking, how would you test upgrades with production data? Again, a very excellent question. And you can do it a couple of different ways. The best way is, in our case, like I mentioned earlier, we simplified our setup because we are using an embedded database. But if you are using Jira in a production scenario, then you are already most definitely using it uh, with uh, with a dedicated database. So for instance, you could be using it with a database like MySQL or Postgres. And what you can and you should do in that case is you can basically create an instance of MySQL or Postgres using Docker, and then you can migrate your data from production into the database container. And you can also link your database container to your Jira container, thus you effectively being able to test your upgrades with production data. In terms of the information that we put out for after the webinar, I'll also include some links, including some by developers from Atlassian, where they have shown examples of creating an instance of Postgres and then being able to link that Postgres instance with Atlassian tool instance inside of Docker. That way, you are also able to load your production data and replicate the scenario, including the type and version of database that you would use to test your upgrades. And let's move on to another question. Let's see. So next question is from Rob, and he's raised the question as to whether we've tackled the issue of two-way application links internally between Docker images running Jira. So I think so far we've not run into this issue. Um, okay. So one of the questions I have for the audience is also whether currently have any of you tried provisioning any of the Atlassian tools within Docker, and what are some of the challenges that you're facing in regards to that? So we'd definitely be happy to hear from your use cases as well as some of the challenges that you faced on your end. So in terms of being able to use Docker with Atlassian tools in a more production setting, I would say the tool that comes closest to that would be Atlassian Bamboo, because with the more recent versions of Bamboo, Atlassian has extended their support for Docker very extensively, because now they provide the ability to communicate with a Docker daemon directly via Bamboo by providing dedicated Bamboo tasks for those, as well as they provide an official Docker image for provisioning Bamboo build agents. So those are two different ways in which Atlassian has increased their support for using Docker even in more production-like settings. So Brendan, I think that's it in terms of the questions we've received so far. Okay, do we have another question? So there is a question from Kerry, and her question is, can you map the IP instead of port number in your container? So Docker does provide the mechanism where you can basically map your port numbers by bridging it with any of the available network interfaces. The method I showed you earlier was probably the most easiest and most convenient way of doing that. But then if it gets especially complicated when you are trying to link Docker containers across different hosts and not just the same host. But there are a lot of third-party and open source projects around solving this problem. Docker recently acquired SocketPlane, which was a startup that was trying to tackle these sort of difficult networking issues with Docker and Docker containers, especially when it comes to running them across multiple hosts. And that was probably the last question we received. But if you guys have any other questions, please feel free to reach out to us after the webinar. And then I believe Brendan has some more announcements before we conclude today's webinar. And thank you everyone for joining. And we'd definitely be happy to hear from you in regards to any of the content we presented today, as well as any other follow-up questions, as well as hearing about your use cases about usage of Docker and combining them effectively with Atlassian tools.
Hey everybody, this is Brendan Kaplan again, Senior Marketing Specialist at AdTech. I want to thank Himanshu for doing such a great job presenting such interesting information. And I also wanted to let everybody know that we're going to be doing a similar webinar on putting Bamboo, like Himanshu was talking about, inside of Docker containers instead of Jira. So I'm going to be sending out an email that has a link to a copy of the presentation you saw today, as well as sign up information and date and time information for that webinar. So thank you all once again. And if anybody needs any help, has any concerns or further questions, please feel free to let us know either by responding to that email that I send out to all of you or by visiting www.adtech.com. That's ADDTEQ. Thank you all so much once again and enjoy the rest of your day. Take care. Bye.